A few months ago, I started making a team. We come from all over the world, and Florida. We may have different backgrounds, but share two different things in common. The passion for one project, and a complete lack of female interaction. We are the L Team. Let me give you some quick context. About 3 months ago, I set out to become better at Valorant, but instead of practicing like a normal person, I followed the dating advice of, if you want to talk with someone, make sure you wait a week to respond to every message. So instead of playing the game, I made a calculator that finds lineups for me. At this point I've added its abilities, visual replaying, different explosion logic to accommodate different projectiles, 2 different maps, first person movement, 3 different optimizations, and then had to remove a third of those features because I changed the entire system so that the code could run even faster. Did that not make sense? Well, Before we get started, it's important for me to mention that none of the new code or other type of work you're going to see in the rest of this video is my own. Instead, as you saw in the intro, a lot of people have been reaching out, and the following is the progress we've made together as a community. The first contributor is Emmett. He is the person that helped transition the code from object-based to vector-based calculations in the previous lineup calculator video, and even though he set the bar high last time, he certainly didn't disappoint. The first thing he added is floor detection. In case you don't remember, floor detection is the only thing that separates brimstone mollies from Viper's snakebite. While Viper's mollies instantly explode if they hit the floor, even though they can bounce off walls, brimstone mollies can bounce against anything and explode depending on other variables. This is a feature I had already implemented, but that was with the old object-oriented method, so it needed an update. If you watched that video, don't skip ahead though, because this is going to show why vectors are so much more efficient than objects for basically everything. Previously, I described floor detection as a frisbee made out of landmines, where if one of the buttons touches the floor, the landmine explodes. The buttons being colliders checking for a collision. But what does it mean for a collider to check for collision? Well, it's simple, right? In human terms, the collider just asks, am I touching anything? But the problem is, what is the eye? All colliders are made out of triangles, even if they don't look like it. This includes the maps and the mollies. So instead it's more like, is this triangle colliding? How about this one? Or this one? Or this one? And so on. It's not as bad as it sounds because computers are good at simple repetitive tasks, but in comparison, when raycasting asks, am I touching anything, it only has to check one line. That's why it's so much more efficient. Points don't rely on complicated meshes. But what about floor detection? If it's a single point, the same point will be colliding with the walls or the floor. Instead, we look if we bounce at the top or the bottom. This is not technically true because it's a point and not a sphere. This means it doesn't have any dimensions and thus doesn't have a top or a bottom. But if we look at the angle of reflection, we can figure out what side it would be bouncing on if it had one. This is all to say that the entirety of floor detection with points and vectors is this. The next thing added is camera alignment, an idea I had that Emmett also implemented. Apparently, a lot of you were not convinced with the idea of just aligning the shot from the calculator in-game by eye, so this is meant to fix that. A lot of you had good ideas, but most had small yet significant failure cases. This is because a lot of them relied on placing marks or lines meant for reference, which can quickly be disrupted with a change of perspective. Instead, I opted for a more permanent solution. After finding a lineup, we can just save its position and angle so that we can point the camera for the lineup. And importantly, it's a different camera that cannot be moved. As long as we disable the now distracting path lines, we can just use this as the exact reference. Temporarily, I also experimented with adding a crosshair in the middle as a little bonus reference, but I opted out of it since we'll just add the entire agent's UI for reference later. Emmett did add a couple more quality of life things, such as having lineup trails not depend on Unity's built-in duels, and make the spike actually look like the spike, but none of this is important if the calculations aren't accurate. And that's where the new dev, Ryouwuta, comes in. Ryouwuta is not a dev in the sense that he didn't code anything, Rather, he's going to be finding the different initial speeds for the different abilities. And rather than using my method of randomly testing until something works, thanks to him being a physics teacher, he calculated the values with a 98% accuracy to the game using real-life physics principles. He gave me the exact explanation, but that's long, and I know a lot of you watching don't have a long enough attention span due to your dementia, so here's the abbreviated version. Using the time to land, the maximum height of a shot, and this formula, we can find the initial velocity because, yes, this is good for the first arch, but for smaller ones, inaccuracy increases due to Valorant's pinging system rounding numbers, the system we're using to get distances. This is because rounding from a small number is more significant than rounding from a larger one. Knowing this, we use the maximum range instead of height, and with some more physics calculations, we get the reduction in speed after bouncing. Added features and accurate calculations are both great, but they're kind of useless if nobody can use them. Another problem that another new dev is helping fix. I Am Online, or just Online, is helping make an understandable UI so that this doesn't keep happening. I don't mind helping people, especially because I have people helping me help people, but I think we can all agree things making sense is just better. I would show you how it works just to clear up any doubts. Unfortunately, for now I only have the outline, but it's looking promising. So I hope you agree that slow but steady is the way to go. I keep saying that people actually believe I have an acceptable upload schedule. Wait. If now you're left there thinking it would have been cool to participate in this project, well, it's not done yet, so you still can. But what's that? You're not good at coding, physics, UI, visual design, helping others learn tax evasion, or don't have extensive knowledge in Valorant's terms of service, experience, reputation, a hairline, body, mental health. Well, the playtesters might be the perfect fit for you. Still not convinced you have what it takes? Here's what they've been up to. Jokes aside, taking into account the fact that we haven't given them anything to do yet, their lack of productivity is not their fault. But that'll change. Alternatively, if you want to be immortalized in this project, we're currently trying to figure out how to get the entire maps with their textures into Unity, given we already have their Blender files. So if you know, please tell me how. Otherwise, if you're crazy enough, we already know how to pass the maps with textures, one object at a time. Finally, even if you don't contribute to the project, please leave a comment with any suggestions of what we should add. I'm hoping to finish this project in only a few more videos, so this is one of your last chances to suggest something that might lead to relatively major changes. I've already seen the requests to add jump lineups and abilities in the other categories, and I can say that one of those is already underway. I know sharing an idea can sometimes seem pointless, but it's important to remember that this entire project started like this. Just one idea from one person, but when shared with others, it became something magical.